Someone is playing music. Shut up on mute. Hey everyone, welcome to another episode of the Common Lisp Study Group. I'm your host, Ron Batum with Atlanta Functional Programming. Today we're going to be continuing our discussion of the intercessory protocols of the AMOP. Those are the protocols that are dealing with kind of extending the Common Lisp language machinery for specialized use cases for we're dealing with like object-oriented programs. Before we begin, just a couple of announcements. One, as I mentioned before, as usual, AFP is looking for people in the Atlanta area to give talks. Please forward me on functionalprogramming.slack or tech404.slack if you're in the Atlanta area, or send me a DM on tech404 with topic ideas, and I will forward them to our organizer. The other thing is of course the Common Lisp Study Group is also looking for people to give presentations on different libraries and projects that they're working on. If you feel like you have an interesting project, it can be anything, and you'd like to present it to our group, please let me know. Again, Discord, Functional Programming Slack, or Tech404 are usually the avenues that I'm almost always available at. Other general announcements. Can't think of anything right now, so let's begin. Last time we kind of left off at this idea of implementing the attributes class example that was in chapter 3. I realized when I was going through that after we ended that a couple of the method signatures in the Closette implementation of the MOP are slightly different than what's available in Closure MOP. So I was hoping to probably go through an example of implementing the encapsulated exercise that's in exercise 3.2 on page 89 and 90, just sort of give you this idea of how to create these extension APIs that are useful for implementing your own extensions of class themselves. So to give some background on this exercise, a lot of object-oriented programming languages, such as that, whether it be C++, Java, Python, and so forth, has, although Python not so much in this case, unless you do certain rules in terms of information hiding, they have very strong support for encapsulation of instance variables. Usually that means not only can you only access a attribute directly using slot values, but subclasses will never be able to access those things. They have to actually call out to some function that internally calls slot value, or the equivalent of this direct slot value, to that instance class so that it could grab the internals of it. This way, the object is truly encapsulated, like the information is really hiding, even in the inheritance hierarchy. Of course, Common Lisp gives us the access to that through slot value, but one way to kind of mimic some of this is to implement an extension class, which I kind of started here in the bottom, that I thought we'd go through. This is, let me just uncomment this section here. Okay. Whoever has the loud keyboard, please put yourself on mute, please. Thanks. The So this is kind of an example usage of this class. You would have a base class that has meta class, encapsulated class with let's say, hold on, this for some reason got deleted when I read, which has some instance variable food, okay, and you have a subclass of C1 that also has the same instance variable. Now, with this encapsulation function, if you want to access the instance variable from the superclass, you would have to do something special in order to grab the internals of that class and then pull out the internal variable contents and then be able to access it from the subclass. Usually in Java, this is equivalent to calling the super method, which is kind of like the base class's pointer inside the subclass. One approach that I was thinking of doing to implement this, and mainly this is related to implementing both the extension and what they call the private slot value in the exercise. This is a function that takes the instance, the slot value that you're trying to find, and the actual class object that you're trying to find that slot value in. And it will go ahead and implement these. It'll go and grab the appropriate value itself. I started kind of working out this exercise, and I thought this would be a good exercise for us to all, try together and see, if there's some ideas on how to implement some of this. Mainly, we start out with, an encapsulated class. Doesn't really do much other than kind of, just adds the meta class data for this. One thing, right, I have to actually add, as usual, hold on one second. As with anything that you want to do in closure map, you have to also add, like we did before, and I forgot about this, is we must validate the superclass. So we call that the override validate superclass on class for encapsulated class and superclass standard class and do that. So now we'll be able to actually go ahead and use this class as if it was a standard class. Now we need to go ahead and implement Mumble, because which requires
live streaming is on.
Which requires, hey, I think Judd, could you put your mic on mute? Thanks. And so now we need to go ahead and implement, I think, private slot value for this class. Now, this should be pretty straightforward from my take of understanding how to do this. So it's just going to be, again, private slot value. This is not a method. It's not a generic method. This is going to just really be a normal function, at least the way I think it should be implemented. Feel free for folks who are more familiar with this, let me know. And it'll take these three values and my understanding is we could simply do that's it. You could call this like private slot value definition, which is essentially kind of like if you guys read earlier in the book on the slot attributes case, it just added a effective slot definition to actually go and use this. But I'm stepping ahead. Let's go and first implement 2 additional overrides that we need to do in order to implement slot value definition. One is the extension that we talked about before, which is compute slots, but we need to first implement compute effective slot definition. And this is where the first thing that I kind of stumbled on, that I needed a little bit of help from some folks who are more familiar with actually adding this, which is in compute slot definition. In the MOP, it takes 3 parameters. One is the class, the other is the name, and the third is the direct slots. Now, I've been trying to find in the book the details of this name argument, but I was hoping if other folks are familiar with it, they could step in and kind of explain what that name is. Okay, so let me go and look this up just very quickly again. I had my thing bookmarked, but for some reason I can't seem to find my bookmark. It fell into the page. So give me a minute. Where was it? It was direct slots. It was compute effective slot definition. Page 177. Right. So the first argument of this guy is our class, which we're going to, specialize to. I think it should be encapsulated class. The second one is the name of the slot. And the third is the direct slot definitions, which they call, D slot DS, which is all the direct slots in the object. Now, if you read the specification, compute effect slot definitions, what it does is it returns essentially an effective slot definition meta object. It determines all the slot definitions for a slot in the class, and it's called by the next method that we need to override, which is compute slots. So the order in which you need to implement these guys here, and I'm going to put the order in that you need to implement these, is compute effect slot definitions, and then compute slots. Now, sorry, just a technical difficulty. Jitsi is complaining here. What's this? All right. So let me go ahead and do this, which is this guy is simply just a union of all the slots that we normally compute, along with the rest of the slot definitions that we end up computing from the base classes that it inherits from. So how would we do this? Let me just go back to one thing here. Notes, which is so we'd first call let on let's do normal slot. Let's create the normal slots, which is the original slot probably associated with this this method. So we call the next method in the method change grab that value. And what we do is we do a setf on the what we call the private slot definition values. And this is going to be a new method that we're going to implement. I'm following kind of the same approach that the attribute example has, just merely because I think that's the correct way of doing it. But again, if folks have other suggestions, feel free to let me know. On the normal slot, actually, this will be this. In this case, this will be the this would be the value of the encapsulated slot definition, I think. This is a lot more difficult than I thought it would be. How would we do this? This is an encapsulated class. So to complete these slot definitions, we need to have you can't just do normal slot because that is metadata on the normal slots. What we want is the private slot value of so to privatize this guy, we would have to first create in the effective slot definitions. What does that mean for a private method, for a private slot value? What would be the effective slot for a private? You wouldn't have to do anything, right? Because you would have to access internally that value. Right. So in this case, I actually think we do not need to really do anything other than call next method, because in this case, the private slot is just going to be an attribute in the class that we need to extend. So let me see here. This would be go ahead and let's try this. So we'll do this. Just call next method. Okay, now we need to do C2 mop. Let's see, compute slots. And compute slots, again, we need to specialize on the encapsulated class. And what we need is the list of a list of the compute slots is also not affected by this. Oh, wait. In order to really do encapsulation, we need to check to see if if a slot value has an accessor, a given slot has an accessor that is a reader or writer, and if it is, we need to throw an error if they try to access those accessors directly. No, because those are messages already. They're calling the slot values. Those are just methods that are just calling the slot value anyway. So what would you need to do in order to make this truly private into a class? That would mean that the effective slot definition has to essentially check to see Rather than seeing me like just pondering here, I'm just gonna go ahead and move along because of the fact that I need to really dig into this example a little bit more, since I don't want to waste your guys' time seeing me struggle here. So Chapter 3 goes through a couple of other existing examples of stuff that's already in class. One is computing, extending the language to have inherent default initialization arguments, which requires some extensions to ensure class, but I don't think we have the ability to do that with closure mop right now. Additionally, it talked about things about pre-computation of initialization arguments for init form that, again, it's a def generic, but unless you're dealing with finalizing the inheritance for a given class, it does not compute those pre-inheritance those default initialization arguments for the entire hierarchy. So it's basically waits until the last minute until the class is kind of being instantiated, where it finalizes the hierarchy for that given class, that it will go through, at least in closed, it will go through and compute all your class precedence lists and your class slots, and then returns those from the function. Now, one question and discussion topic that I wanted to ask and I wanted to pose to the group here is there's a section on slot access that I didn't quite understand, particularly in in 3.7. I don't understand when this will be used. Slot value using class. This generic, according to this, it says this generic function provides the behavior of slot value. Slot value is called. It calls this generic function, and which then passes in the instance and the slot name, and it returns the value that slot value ultimately returns. But it doesn't actually say what it is that it's looking at. The basic implementation, from what it looks at, is that slot value using class goes into essentially the heap allocation of the instance and computes the offset where a particular slot value is located and then returns it. But I'm not sure if that's the case if you look at the code on page 97.
Yeah, Ron, those functions, I'm sorry, I stepped away for a minute, but those functions that you're talking about in 3.7, that's for the per class, you can override slot value and set slot value on a per class basis. So if you wanted to have a different behavior than default behavior.
Interesting. Okay.
So like the example they had is they implemented a logging system using it, right? So instead of just getting the value and returning the value, it would log when somebody was setting the value or getting the value or doing checking to see if it was bound or making it unbound or whatever, and it would log all those calls to the instances.
Oh, that makes sense, actually. You're talking about the history example that's on page 98, right?
Right. Yeah.
Okay. Interesting.
Yeah. That slot thing where it takes the class in is just the mechanism I had to add to the mop, so that way you can override the behavior of slot value and set slot value on a per class basis if you wanted to.
I'm wondering if that's even available now in the mop.
I would imagine it would be because it's part of the definition. So.
Okay. No, there's a couple things that Cosette like added in terms of method signatures and stuff that I was just I was like, okay, they changed the implementation to simplify it for us, but I didn't think that was has what's it? I thought it was still using the method signatures that they would ultimately be in the mop itself. So I'm trying to find the differences between the two. Okay. All right then. Um, let's try. So let me try something here. So if you're gonna do, this is gonna be. Let's see here. So those are slot accesses. Okay. So the last topic of chapter 3 that that's a pretty big topic is how do we deal with instance allocation? Now, for folks who are familiar with other languages, this usually means, especially in like C++, or implementing malloc if you're using C. In Java, you don't have this kind of ability, particularly because of the fact that at the end of the day, all objects follow the root single hierarchy, and Java doesn't have a Metaobject protocol for you to actually go in and modify this. Now, again, in this case particularly, there is some metadata associated with hooking into the Lisp machinery that just are required. That is the metadata associated with T and standard object. But after that, how you allocate the stuff related to your user-defined class or meta class is entirely up to you. And there are certain nice functions that are available in the Metaobject protocol that give you the ability to override some of that. One of them is and I'm just going to show you the method signatures here because I didn't have time to actually come up with an example of this. My apologies. This is this is C2 mop allocate. What is it? Is does it not have the allocate instance thing that I saw? That might be mop specific. Give me just 1 second. I gotta go and pull it up again. It was closer mop. Documentation. Huh. I thought this was part of closure mop, but let me see. Allocate instance function. So the first one is allocate instance. This is a standard function that's actually in the common Lisp standard. This is something that you could. My understanding was you'd be able to override this guy, but I thought it was a generic function, but I can't really tell here. Oh, it is a generic function. So you can see here that and if you inspect, it's an instance of funcallable standard object. So what you could do is you can actually override. Pretty sure you could do this. Let's see here. Let me just see if you could just. Without actually blowing away my Lisp image, because then this will be an unfortunate thing. You can actually do, I think, a def method on allocate instance. Let's see. See class. Let's say counted class for the time being, which is hold on. Let me first switch us to our samples namespace so I don't blow away anything in my root. Allocate instance class, counted class, and attempt to add the method to the generic function. Oh, right. I did not implement the signature completely. Rest init args. Now, doing this, by the way, and not implementing anything will mean that I'm pretty sure it means that no matter what, the function will not allocate this guy. style warning. Yeah. Then if we do a make instance on, let's say, counted 2D point, x chord 0, y chord 0, we'll see that counted 2D point. Right, that's right, because we overrode allocate instance. Allocate instance is what you'd use to actually go and call, this storage, and there are other things that are available to you in the standard for this. Allocate instance calls actually a couple of methods called I think it's still allocate standard instance, and but I could be wrong. Yeah. So while the method is there, the generic method is there. It looks like Closette added a bunch of functions that the MOP doesn't actually, at least from what I can tell, does not specify in terms of how you do what's a standard interface for instance allocation. So one suggestion is, according to the specification, let me just pull up the specification here before we move forward. And page 168. Okay, so the value returned is a newly allocated instance of the class. The purpose of this thing is to create a new uninitialized instance of a class. The interpretation of the concepts, and this is, I'm reading the function signature for allocation of the uninitialized instance depends on the class Metaobject class. Before allocating a new instance, class finalized P is called to see if a class has been finalized. Otherwise, it calls finalize inheritance before the new instance is allocated. So, there are a couple of already built-in methods for this class. One on standard class, the other on built-in class and fun-callable class. But for user-defined classes, you can do whatever you want if you want to. So user-defined classes, as long as sorry, not user-defined classes, user-defined class meta objects, you're pretty much open to figure out how to do allocation. Now, one thing I'm going to mention is and I understand now why they didn't specify this. Allocation tends to be a very Lisp implementation specific thing. So depending upon your Lisp implementations, they may give you an API to do some advanced heap allocation that other Lisps may not provide. So while there is a standard interface for allocating instances, there's no portable way of doing instance allocation because, and this makes sense, since you have an interactive environment, you're going to have to go and hook into the specific Lisp implementation to deal with its registration of the object to the garbage collector and allocator. And those interfaces, as far as I know, are not open to folks to mess around with. Some implementations may have them available to you, others may not. So that's chapter 3. Are there questions? Any general topics of discussion? Comments from our audience in YouTube land? Michael, do you have any, Fiano, do you have anything to add? Okay. That's it. Looks like this is going to be an early session today because I have nothing else prepared. I will leave you guys with next week. We're going to be covering chapter 4. I'm going to review chapter 3 one more time. Examples for the